An epic war has raged between the evil wizard and the helpless T Squires, a battle that has endured since the dawn of time itself. Yeah, I'm just kidding. It's only been since the 60s, but that doesn't sound as dramatic. Anyway, the battle I'm referring to is none other than the one against HIV. So let's draw in our white wizard here who will represent HIV, also known as human immunodeficiency virus. HIV is a member of the lentivirus genus, which is a part of the Retroviridae family. All members of this family are retroviruses, and HIV is no exception. We'll come back to what this means in a bit. The vast majority of untreated HIV infections eventually lead to AIDS, or acquired immunodeficiency syndrome, which, like the name suggests, is an immunocompromised state. Notice he wields power through a crutch like staff, a recurring sketchy symbol for immunocompromised. There are, in fact, two types of HIV, HIV-1 and HIV-2. HIV-1 causes the majority of infections worldwide, and nearly all cases in the US. It's scary and virulent, just like our scary, dangerous wizard. On the other hand, the wizard's henchman is less scary, just like HIV-2. HIV-2 is really only prevalent in certain regions of the world, including West Africa, Portugal, Spain, and India. HIV-2 is also less virulent, which translates to lower levels of virus in the bloodstream. As a result, HIV-2 is less infectious and leads to a slower decline in immune system function. We'll focus on HIV-1 for most of this discussion. HIV is a single-stranded positive sense RNA virus. Notice the warm orange hues representing an RNA virus, plus the positive sense sun. As we mentioned earlier, HIV is a special kind of positive sense RNA virus, a retrovirus. This means the virus converts its RNA to DNA by an accompanying enzyme, reverse transcriptase, or in wizard lingo, reverso transcriptome. Thank you, wizard. The resulting DNA intermediate is then integrated into the host cell genome where it replicates along with the host DNA. Which is why, as you can imagine, it forms a chronic disease and how it became a slow virus, or a lentivirus. All right, let's move on to the structure of the HIV virion. At the very core, you've got the genetic material. HIV has a diploid genome, meaning each virion contains two copies of its positive sense single-stranded RNA genome. See the two orange dragons at the very center of the wizard's cap? Orange for RNA, of course. The RNA strands and their accompanying reverse transcriptase are surrounded by a conical, i.e. cone-shaped capsid, hence the wizard's cone-shaped hat. Before I go on, I have a little disclaimer. I'm going to be talking about a lot of different proteins, all with letters in front of numbers, GP120, GP41, P24, and so forth. Unfortunately, the structure of HIV is something that's often tested. Normally, these are categories of proteins, and we'll go into these in the next video. These categories are GAG group antigen proteins, or capsid proteins, POL for polymerase, reverse transcriptase, and ENV for envelope proteins. Luckily, we've already knocked out one category, and that's POL. The only protein you need to remember for POL is reverse transcriptase. GAG proteins are associated with the viral capsid, the inner shell of the virus. The capsid is composed of many subunits of the P24 protein. To remind you that P24 is associated with the capsid, we've drawn the sundial on the brim of the wizard's hat. 24 hours a day for P24. And just as a brim surrounds the wizard's conical core hat, so too do these capsid proteins surround the viral core. The capsid itself is surrounded by another layer. Next comes an interwoven matrix that connects the core to the envelope. Here you'll find the P17 matrix protein. Our wizard has come prepared for battle, protected by a chainmail undercoat and a dagger and a sword combo that form the number 17. Remember, the chainmail undercoat is to remind you that the P17 matrix proteins are beneath the viral envelope. Directly overlying the P17 protein shell is the envelope, hence our wizard enveloped in a large robe. The envelope is composed of a lipid bilayer studded with glycoproteins. These ENV proteins, or envelope glycoproteins, are actually complexes of two glycoproteins, or GPs. There's GP41 and GP120. Both exist as trimers, and will represent both on a pipe. GP41 is a transmembrane protein, so we have 41 here on the stem, or the mouthpiece of this pipe. And if you think about it, a mouthpiece is technically transmembrane. Notice for the pipes in his pocket, the stem reaches deep into his robe pocket, just like a transmembrane protein extends deep into the membrane of the envelope. GP120 is the outer glycoprotein that will eventually come in contact with host receptors. So we've incorporated a 120 into the outermost part of the pipe, which is the bowl. And just so you never forget this, there's another reason we've represented this with the pipe. Because if you remove the ones, then you have 420. 420 is, of course, the internationally recognized weed day. So we think having 420 inscribed on a pipe is pretty fitting. HIV specifically targets the host CD4 positive immune cells, which includes both helper T lymphocytes and macrophages. Notice the wizard about to face off against this helper squire, who has a 4-shaped strap incorporated into his outfit. He represents CD4 positive T lymphocytes, also known as helper T cells. It's no coincidence that HIV targets CD4 positive immune cells. As it turns out, the primary receptor for HIV is CD4 on the host cell surface. In order to gain entry to the host cell, HIV must also bind a co-receptor from the chemokine receptor family, either CCR5 or CXCR4, represented by a CCR5 banner and a CXCR4 flag. CCR5 is associated with T cells and macrophages, while CXCR4 is primarily found on T cells. Generally, HIV is tropic towards one of the two co-receptors, meaning it has a preference for one or the other. HIV strains that use the CCR5 co-receptor are known as R5 viruses. These predominate early in the course of HIV infection. We know that CCR5 binding is an important virulence factor in part because we've seen some individuals with CCR5 gene mutations that make these individuals virtually resistant to HIV. They can maintain normal CD4 counts and don't progress to AIDS. This is why the CCR5 co-receptor is an important therapeutic target. But more on that later in part 2 of our saga. However, the majority of hosts are susceptible to HIV's ability to enter the cell through binding of the CCR5 co-receptor. And like other viruses, HIVs develop the ability to acquire new virulence factors that enable its entry into host cells. In fact, later in the course of infection, some HIV strains acquire the ability to use CXCR4 as a co-receptor. Those that exclusively use CXCR4 are known as X4 strains. Some strains can actually use both co-receptors, and therefore are known as R5X4 viruses. All right, let's move on to transmission. It's no surprise that HIV is transmitted through body fluids, represented here by the wizard set of potion bottles. The red one's easy. HIV is a blood-borne pathogen, so exposure to infected blood is a risk factor, whether in the form of IV drug use with shared needles or an accidental needle stick. HIV can also be transmitted through blood and organ donation. Fortunately, broad screening practices have reduced the risk of transmission in these cases to a very low level. HIV is, of course, also sexually transmitted. Hence the less colorful potions, which represent semen as well as rectal and vaginal fluids. HIV can also be passed from mother to infant. This is known as vertical transmission, and can occur during pregnancy since the virus crosses from mother to baby via the placenta, during labor and delivery, or through breastfeeding. And I don't want to know what this wizard's going to be doing with these body fluids, so let's move on. Once a person is infected with HIV, the disease progresses through a series of stages. Ooh, watch out! Unfortunately for these squires, the wizard's firing off bolts of orange and blue magic. Fortunately for us, these brilliant magic beams illuminate some key points. The orange beam of light represents the level of HIV viral RNA in the plasma. We're talking HIV's positive sense RNA genome here. So this magic beam is similar in color to the positive sense sun. This RNA level is also known as the viral load. The blue beam, on the other hand, represents the CD4 T cell count. And you'll notice it's taking out a poor helper T squire. Initially, HIV replicates unchecked because the host's immune responses have yet to fully develop. The result is a rapid increase in viral RNA. This is accompanied by a decline in the blue CD4 T cells. Yeah, at least temporarily. During this early stage, many patients develop symptoms of acute HIV infection, also known as acute retroviral syndrome. This presents with a cluster of nonspecific symptoms, sometimes described as mono or flu-like, and most notably fever and fatigue. Take note of the recurring feverish flame helmet, and pay attention to where this vile creature is standing, namely right below that early spike in viral load. The symptoms typically resolve on their own within a few weeks thanks to a robust immune response, including the production of anti-HIV antibodies, which neutralize circulating virus, leading to a decrease in viral load. After this initial acute phase comes a long asymptomatic period known as clinical latency. This lasts around 8 to 10 years, or around a decade. Check out this book's location. It's above where that orange annihilation beam has flattened out somewhat and hasn't shot up again yet. This is because the host's immune response is keeping the virus in check, to some degree, but only to some degree, because HIV is doing its darndest to destroy CD4 helper T cells during this time. So the book is also above where that blue death ray is slowly decreasing, but hasn't totally tanked yet. But unfortunately, all things must come to an end, including clinical latency. By this point, the CD4 count is starting to tank, and it's not a coincidence that this is when the viral load starts to drastically increase. Notice how the blue beam is attacking that squire on the floor while the orange one takes a sharp U-turn upward? See, by now, the wizard has quietly plucked off one helper T-squire after another, until the squired T-cell army is too small to mount an effective immune response against it. And that's how this wizard creates the immune-compromised state known as AIDS. To be technical, there are two ways to diagnose AIDS. The first is based on CD4 counts alone. Anything below 200 is, by definition, AIDS. The presence of an AIDS-defining illness is the second way to diagnose AIDS. These tend to start occurring around a CD4 count of about 200 anyway, but not necessarily below 200. So what exactly is an AIDS-defining illness? Well, these are characteristic syndromes that occur as a result of immunosuppression due to the depletion of CD4 T lymphocytes. Many of these illnesses are opportunistic infections, including fungal, bacterial, viral, and protozoal infections. Basically every type of infection. Hence basically every type of lantern hanging from this creepy shelf. Certain malignancies can also be AIDS-defining. These are often mediated by an oncogenic virus, like EBV, HPV, or HHV8, the virus that causes Kaposi sarcoma. Normally, an intact immune system prevents these viruses from causing malignancy. However, the chronic immunosuppressive state from AIDS allows them to run wild. As you travel the sketchy universe, you might come across an AIDS ribbon here and there. This represents an AIDS-defining condition. All right, and finally on to testing for HIV. Screening for HIV typically starts with the fourth-generation test. This can detect the presence of HIV-1 and 2 antibodies and the HIV P24 antigen. That's why this elven archer is decked out in a combo of 1 and 2 antibody arrow quivers and a 24 sunburst dial. The test is positive if either antibody or antigen is detected. If the 4th-gen test is positive, the next step is an antibody differentiation immunoassay. In most cases, this will confirm the presence of antibodies and differentiates between HIV-1 and HIV-2. Notice the 2 different antibody arrows. Well, this is to remind you that this follow-up test can differentiate between the 2. But what if the 4th-gen test is positive, but the follow-up antibody tests are negative? Well, you guessed it. Detection of P24 antigen is likely responsible. And furthermore, the person likely has acute HIV infection. That's because antibodies need time to develop. So there's a so-called serologic window between infection and the appearance of antibodies several weeks later. But certain tests that detect pieces of the virus become positive earlier on. This includes the P24 capsid protein as well as viral RNA itself. So acute HIV infection can be confirmed with HIV RNA nucleic acid testing, also known as NAT or NAT. This swarm of gnats next to the positive sense RNA sun are here to remind you that NAT or NAT is used to detect HIV RNA. All right, that wraps up HIV Part 1.